The second part of 6.2 is about finding the factors. So what is the meaning of a factor? Factor means that your remainder is 0. So how to find factors? The first method is by using long division, and you can see that the remainder is 0. So the moment you can see that the remainder is 0, this means that your divisor is a factor. The second method is the factor theorem. So if you get the remainder is 0, this means that your divisor just now is a factor. So let's look more into factor theorem. If px is divided by x minus a and the remainder is pa equal to 0, therefore x minus a is a factor. So if you look at this equation, this is the original equation of px. And if you get the remainder is 0, this means that rx is 0. So we can ignore rx. Hence, px is just qx times dx. Sometimes you may need to use px equal to qx dx, but sometimes you may not need to use it. So let's look at example 4, question 1. Given that x plus 2 is a factor of this polynomial, hence we need to find the constant k. So recall, factor means that your remainder should equal to 0. Hence, we can use the factor theorem in order to find the constant k. But first thing first, if you're not given px, you need to let px. So this is our polynomial, which is px. Since we already know that x plus 2 is a factor, I like to write factor x plus 2 so that you can remember that x plus 2 is a factor. So this means that your answer should equal to 0. When you let x plus 2 equal to 0, that will give you x equal to negative 2. So substitute x equal to negative 2 into px. And we already know that the remainder is 0, so this is equal to 0. And hence, k is negative 8. For question 2, this polynomial px has a factor x minus 3 and a remainder which is 18 when px is divided by x minus 1. So we need to find the values of a and b, and hence we need to factorize px completely. So let's try and find the values of a and b first. This is our px, and it has a factor x minus 3. So let's apply factor theorem for x minus 3. And since this is a factor, therefore the remainder is 0. Therefore, 9a plus b is equal to 35, and that is our first equation. But don't forget about the remainder 18 when px is divided by x minus 1. So now we need to apply the remainder theorem for x minus 1. And note that when px is divided by x minus 1, it gives you remainder 18. So this is equal to 18. And we will get a plus b equal to 19. So that is our second equation. And hence, a is 2 and b is 17. And now, we need to factorize px completely. This is our original px, so substitute a and b into px. Now, let's look at this example. 21 divided by 7 will give you 3. Since it is exactly 3, therefore, this means that there is no remainder. And hence, 7 is a factor of 21. Therefore, your divisor is 7, which is a factor. So, using this concept, you can see that we can let factor to become dx. And we already know from the question that we have a factor which is x minus 3. So, we can let x minus 3 to become dx. So, since we need to factorize px completely, this means that we need to use long division. Since this is 0 divided by x minus 3, which will give you 0, so we can ignore this part. So it is just 2x squared minus 7x minus 4. Note that we want to factorize px, so we only need px. Eliminate x minus 3 by multiplying everything with x minus 3. And we need to factorize px completely. And that is how you factorize px completely.